Okay, this is about polynomial graphing and solving polynomial inequalities. And so in class, before all of the craziness, before spring break, we had already discussed how to graph polynomials, plus you saw that in college algebra. So we're going to recap it quickly here, and then we're going to use the graphs from polynomials that we graphed to solve polynomial inequalities. So as a reminder, an inequality is when you replace the equal sign with an inequality symbol, such as greater than or equal to, greater than, less than or equal to, or less than. So this is going to be our plan. We'll be given an inequality to solve, a polynomial inequality. We will graph it. So we'll find the zeros and their multiplicities. We'll find the end behavior. We will sketch the graph, and then we'll answer the question. So you have a worksheet to go along with this. So I'm going to be going through the worksheet, and you can do it with me. The first one that we have here is P of x is equal to x plus 3 times x plus 2 times x plus 5. So let's find the zeros, which are x-intercepts. If we set this equal to 0 and solved, we would get that x is equal to negative 3. This 0 has a multiplicity of 1, which means since it's an odd multiplicity, it will cross at the x-axis. This 0 is x is negative 2. It has a multiplicity of 1. It will cross at the x-axis because the multiplicity is odd. This 0 is x is negative 5. It has a multiplicity of 1, and it will cross at the x-axis. The end behavior is determined by the leading coefficient and the degree of the polynomial. The leading coefficient is positive. I don't see a negative up there. And so positive means that it's going to be up to the right. And then the degree is, you can find that by saying x times x times x will give me x to the third, or by just adding up the multiplicities. 1 plus 1 plus 1 is 3. The fact that the degree is odd means that the left behavior will switch. It will not follow the right. It will be down to the left. So that's the end behavior. Let's make a quick sketch of this graph. Let's identify the zeros. Here is at negative 5. Here is negative 3. And here is negative 2. Okay, so our graph is down to the left, so means all the way to the left it's going to be coming up, and it's going to cross, it's going to cross, and it's going to cross. We already figured that out. So it's going to cross, it's going to cross, and it's going to cross. Again, this is a sketch, so this is not a really accurate graph, but for our purposes, we're solving polynomial inequalities. We will use it to that. So for number 1, I said, let's figure out the answer to this. When is P of x greater than or equal to 0? All right. What this means is where, for what x values, is the y positive, greater than 0, or equal to 0? We know it's equal to 0 at the zeros, negative 5, negative 3, negative 2, and it's positive at this portion up here and this portion up here. So I'll highlight that with a different color marker. Where is it? Let me just do this because we'll do a few different scenarios. For greater than or equal to 0, where would that be? Equal to is at the zeros, so this, we include this, and then it's going to be this part and this part, okay? So we would include all of that part. This would be from negative 5 to negative 3. And then we're going to union that. Don't talk about where it went negative. We're going to union it from negative 2 to infinity. That's where this guy is, positive or equal to 0. What if, for instance, they said, don't talk about where it's equal to 0. What if they said, where is this? P of x is just greater than 0. Then the only thing that would change would be that we would not include those points. We would just include where it's positive. So what that would look like would be from parentheses, negative 5 to negative 3, union with negative 2 to infinity. That would be the answer to that. What if they asked us, where is it less than or equal to 0? What would that look like? Where's P of X less than or equal to 0? That would be down here. That would be, or equal to would be here, right? And then less than would be this part down here. This would be the part that we would include. The purple is what we would include this time. So we would say from negative infinity, marker's dying, to negative 5. And again, it's a bracket on the negative 5 because of this or equal to, and then we would union it with negative 3 to negative 2. Just like that. Okay, that's the first one. Here is, I think I just have a few of these for us to do. Let's look at number 2, which is Q of X. So number 2 is this, Q of X. Q of X is equal to X plus 5 squared, 4x times 4x plus 3 times x minus 4. And so what we're supposed to solve here is where is this greater than 0. So let's just go ahead. I'm going to erase the top part so I can use this space. What would be the zeros for this? The first one that I see here is x is negative 5. If you set this Q of x equal to 0 and solve, that gives you the x-intercepts, also known as zero solutions or roots. So for this one, we would say that the zeros are x is equal to negative 5, which has a multiplicity of 2. The fact that the multiplicity is even means that it will bounce when it, or touch and turn when it gets to the x-axis here. So x is negative 5, it has a multiplicity of 2, it will bounce. X is negative 3/4, it has a multiplicity of 1, it will cross. And x is equal to 4, it has a multiplicity of 1, it will cross. And so the end behavior, let's see, it's positive, that means up to the right. It is, the degree would be 2 plus 1 plus 1, which is 4, which means that since it's even, it will, the left behavior will follow the right. It's going to be up to the left, up to the right. So if we're going to do this, let's mark our zeros. This is negative 5. This is negative 3/4. And this is 4. Of course, this is not to scale, and that's not a big deal because I'm using this sketch to answer this question, and that's really all I need. The maxes and mins are not where they would be precisely. That's okay, because again, we're just using this to answer this question. If we needed a super accurate graph, we would use our graphing calculator or plot a bunch of points to make it very accurate. But what we're after here is just solving this equation. Okay, up to the left means it's coming from up here. When it gets to negative 5, it's going to bounce. So it's up here, it's coming down, it's going to touch and turn, go back up. It's going to cross when it gets here. Somehow it's going to go up, it's going to cross, and then it's going to cross. All right, let's answer this question. Where would this polynomial be positive? That means don't include the zeros. Only include the part where it's up. So what we're going to include on this one will be simply this part, and this part. So how we would answer this would be from negative infinity to negative 5. But don't include negative 5 because no or equal to. Union with negative 3/4, no, sorry, negative 5, negative 5 to negative 3/4, it's not right, from here to here, and then from 4 to infinity. Now this one's interesting. Oh, my phone's going on, sorry. If we were going to, that's a little distracting, sorry. If we had just greater than or equal to, let me see if I can turn that off. Sorry, can I decline? Okay. If we had greater than or equal to, we would answer it like this. If it was greater than or equal to 0, then that would be from here, we would include this point, And we would include this point, and we would include this point. So that would be from negative infinity to -5. Oh, no, we wouldn't have to stop. Since -5 is included, we would go all the way from here to -3/4. And then we would union it with 4 to infinity, just like that. And so that's how we would answer number 2. Let's do 3. Number 3 looks like this. M of x is equal to negative x plus 2 squared times x minus 3 times x plus 4 squared. And we want to know, where is this guy less than 0? So let's go ahead and say, what are the zeros? First one is going to be x is equal to -2, and it's got a multiplicity of 2, so its behavior will be touch and turn. Also, you could say it bounces. So the zeros, x is -2, it has a multiplicity of 2, it will bounce. X is 3, it has a multiplicity of 1, it will cross. X is -4, it has a multiplicity of 2, it will bounce. What is the end behavior? Well, the leading coefficient is negative. That means it's going to be down to the right. What is the degree? 2 plus 2 plus 1 is 5. That is an odd degree. That means the left behavior will switch. It's going to be up to the left. That's the end behavior. Here is our little sketch. We'll go over here to -4. Here is -2. And over here is 3. Okay? So let's sketch this guy. It's up left. That means it's coming from up here on the left. And when it gets to -4, it's going to bounce. So we're up here. We're going to bounce. Get to -2. It's got a multiplicity of 2, which means it's going to bounce. So it's going to go up. It's going to bounce. And then it's going to cross. Oh, that's an arrow. It's going to cross for 3. Okay, so that is our graph. Now let's answer the question. Where is this negative? Where is it below 0? Well, okay, let's look at this. Positive equal to 0, positive equal to 0, positive equal to 0. This is only negative from 3 to infinity. All right, that is number 3, the last one, and then we're done. Let's solve this one. R of x is equal to, let's see, negative x squared times x minus 4 times x plus 2. And what we want to know here is, where is this guy less than or equal to 0? So let me make space for this one. The zeros. The first one, the first 0 is x equals to 0. So sometimes that's hard to spot, but you can think of this x squared term as x minus 0 squared, if that is helpful. But the first 0 is x is equal to 0. It has a multiplicity of 2. It's going to bounce. X is 4. It has a multiplicity of 1. It's going to cross. X is -2. It has a multiplicity of 1. It's going to cross. The end behavior, negative. That means it's going to be down to the right. Let's see. If I add up the multiplicities, 2 plus 1 plus 1 is 4. That's even. That means the left behavior will follow the right behavior. So here we go. We have zeros at -2, -2, at 0, and at 4, All right. So down to the left, down to the right. So we're down here, and we come up to -2, and we're going to cross. So we're going to cross, and when we get to 0, it has a multiplicity of 2, which means it's going to bounce back up, and then at 4, it's got a multiplicity of 1, so it's going to cross, and we get kind of like an M shape. If we're supposed to answer where is this less than or equal to 0, then we have to talk about, let me highlight this in red, where is this negative or equal to 0? Then that means this is where it equals 0, this is where it's negative. Right here at 4, it equals 0. And this is where it's negative, and this is where it equals 0. We have to include all of those red points right there. So this will be, our answer to this will be from negative infinity to 2, include the 2, union with just 0, just that one little point, x is 0, union with 4 to infinity. And this is poorly drawn. That looks like it's gone vertical, but it really has not. So let me just fix that. Okay, polynomial inequalities.